Hello, my name is Mark Sapiri. This is the second video in an overview series of the first 3 chapters of the book From Quantity to Number. It's available for sale at any of the Amazon sites, and there's more information at inletbooks.com. This book is a first course in mathematics intended for parents and students interested in a discussion-based math program for their homeschool curriculum. This video features some of the ideas from the second section, How We Build Numbers, of Chapter 1, Beginning Counting. In learning to count, the question we are approaching is, what is a good way to name quantities? If we are concerned with only a few quantities, the simple answer is to have a different name and symbol for each number. For example, if we're only concerned with 3 quantities, 1, 2, and 3, then any 3 symbols would work. We can express these quantities each with its own symbol. A challenge then arises when we realize we would like to count a quantity bigger than this. How would we do that? One approach would be simply to add a new symbol to our set of numbers. That's fine. But if we decide later that we want to count another bigger quantity, then we're facing the same question again. In fact, it doesn't matter how many symbols we create to designate quantities, there will always be another quantity that is bigger. For example, if we have 4 symbols, and so we can count 1, 2, 3, and 4, we still might bump into the quantity 5, for which we would need another symbol. Our number system lets us describe and write quantities as big as we want. The key to this is the idea of counting groups. For this, we will need a collection of symbols, names for counting the first several quantities. And then we need a method for indicating how we count groups. This is a common experience, by the way. For example, you might count pairs of shoes rather than individual shoes, or eggs by the dozen. It does not actually matter how we count groups. But our system for building numbers is based in the number 10, perhaps because we have 10 fingers. 10 is a convenient quantity for us. In any event, there are 2 key milestones in learning to work with numbers in our system. First, to understand the symbols for the 9 numbers and 0, the symbols for 1 through 9 let us express quantities up to 9. We must also understand the symbol for 0, which means nothing, no quantity. Second, to understand how we count groups of quantities as well as individual quantities. The student must first understand the 10 basic symbols. 9 numbers for quantities 1 through 9 and the number that we call 0 for nothing. We refer to these 10 numbers as digits, especially when we use them to build bigger numbers, as we will see. Students must practice recognizing these numbers and writing them. In this, it is also helpful to notice the relationship that we can build each successive number by adding 1 to the preceding number. For example, if we add 1 to 5, we get 6. Likewise, if we add 1 to 2, we get 3. There are lots of ways to practice understanding these numbers, referring to things around the student. The book contains numerous examples and exercises for practice. So far, we have counted up to 9. If we have 9 pencils and we get 1 more, then we have 10. We write the number 10 as a list of 2 digits. The key to understanding the meaning of this list is to understand what each digit counts. The digit on the right counts ones. In the list 1, 0, that digit is 0. We are counting 0 ones. The digit on the left counts tens. In the list 1, 0, 1 means we are counting 1 10. The number that we write as a list of 2 digits, 1, 0, means that we are counting 1 10 and 0 ones. Notice, by the way, the great usefulness of the symbol for 0. It lets us write the number for 10 by indicating that we count 0 ones. If we wrote just the symbol 1, that would be counting 1, 1. If we wrote the list 1, 1, that would be counting 1, 10 and 1, 1. That is the quantity 11. It is worthwhile for students to work patiently to master these two ideas for understanding the meaning of numbers, and the book includes many exercises to help in this. For example, what is the meaning of the number that is the list 1, 8? It means that we're counting 1, 10 and 8 ones. Notice that for practice, we can ask questions going the other way. For example, how do we write the number for the quantity counting 1, 10 and 8 ones? What is the meaning of the number that is the list 2, 8? This means we're counting 2 tens and 8 ones. What is the meaning of the list 5, 0? This means we are counting 5 tens and 0 ones. What is the biggest number we can count, we can build with 2 of our digits? The biggest single digit that we have is 9. So the biggest number we can build with 2 digits is the number counting 9 tens and 9 ones. So what if we have 9 tens and 9 ones? The name is 99. We have 99 tennis balls, and we find one more. How do we write that quantity? We use the same idea again. We reuse the symbol 1, but to count the quantity that is 1 bigger than 99, 100. A big advantage to teaching and learning early how to count into 3 digits is that this lets us ensure the student really understands the meaning of numbers, that is, what they count. With 3 digits to work with, we can play around with the concept of counting by group in base 10. The book contains many exercises and examples for this. What does the list 504 mean? It means we are counting 5 hundreds, 0 tens, and 4 ones. What about the list 514? Now we're counting 5 hundreds, 1 10, and 4 ones. What if we wrote the list 540 instead? Now we mean to count 5 hundreds, 4 tens, and 0 ones. What about the list 405? This means to count 4 hundreds, 0 tens, and 5 ones. Notice that in these numbers, it is not the meaning of the digit symbols that changes. The key point to understand is, what does the digit count? In the number 504, the digit 5 counts 5 hundredths. In the number 405, the digit 5 counts 5 ones. Once the student is comfortable with the meaning of numbers, the list of digits up to 3 digits, it will be very easy to learn the naming conventions. For example, it is easy to go through the names of the decades, noting the pattern: 10, 20, 30, 40, 50, 60, 70, 80, and 90. The decades end in the suffix ty. The first part of the name derives from the number counting tenths. For example, in 60, we are counting 6 tenths. The next naming convention to clarify is for the teens: 13, 14, 15, 16, 17, 18, and 19. Here the 10 count is indicated by the suffix teen. Once the student is comfortable with the names of the decades and teens, a good way to confirm understanding is to examine the process of stepping from one decade to the next. For example, if we count up from 8 tens and 9 ones, 89, what is the next number? This involves the key incrementation relationship underlying counting. Incrementation will also be useful in addition, and it is an example of a process that has many other applications too, so it is one of those concepts worthwhile introducing, spotlighting early on. If we are counting 8 tens and 9 ones, and we add one more 1, now we have 8 tens and one more 10. What does this count? It counts 9 tens. And we write this as a list, 90. Its name is 90. Our system for building numbers is based on 10 symbols, 1 through 9 and 0, and also on the idea that we count groups of 10 or groups of 10, like 100. It is worthwhile to keep in mind that we could have built a number system differently. For example, we might just have used different symbols, or we might have used different symbols and a different approach to counting groups, like the Romans and Roman numerals. Learning the Roman numerals can be a good exercise to appreciate what is particular to a number system. The book includes examples to this effect. The student might also devise other systems based in different numbers. That is, instead of counting groups of 10, we might count groups of 20, or 60, or 12, or 2. We'll return to this subsequently when we have studied the base 10 system a bit more, because translating numbers from one base to another is an excellent exercise for understanding how a number system works and what it is doing, what numbers mean. It is fine, by the way, even desirable to cycle through these concepts while teaching them, cycle through them iteratively as the student puts them all together. In the next video, we will discuss counting by groups of 10.